The moment the captured Ki-43 arrived at the airfield, American pilots and ground crews could hardly believe their eyes. A lightweight, seemingly fragile Japanese fighter sat on their tarmac, its sleek fuselage and delicate frame radiating an almost unreal elegance, so unlike the heavier, more robust aircraft they were used to flying and maintaining. And immediately whispers began to ripple across the hangar, some skeptical, some anxious, some tinged with disbelief as the pilots approached, assessing every curve, every control surface, and every panel of the aircraft as though they were encountering a new species of flying machine. And the first pilot to climb into the cockpit felt a mixture of thrill and apprehension as he settled behind the deceptively small control stick, the pedals underfoot, and the seat that seemed almost too narrow for a man accustomed to larger, more forgiving cockpits, while the ground crew buzzed around him, performing quick checks of fuel, hydraulics, and control surfaces, all the while sharing stories of dogfights over the Pacific, imagining how the original Japanese pilot had maneuvered this aircraft to evade much more powerful opponents. And then, with the engine roaring to life, a sound far quieter and higher pitched than any American engine of the era, the aircraft rolled onto the runway, its weight surprisingly light under the pilot's hands, and as it lifted into the air, the first minute of flight produced an almost immediate sense of disbelief and tension, as the aircraft responded with uncanny agility to even the slightest control inputs, banking sharply, climbing steeply, and twisting in maneuvers that seemed impossible for its size, making the pilot feel as though he were controlling a delicate toy. A paper airplane in the sky, yet one that was alive, capable, and terrifyingly responsive, and as he looped and rolled, the mechanics on the ground scrambled to track every motion, noting the extreme thinness of the wings, the sensitivity of the ailerons, the way the tail responded almost instantly to rudder inputs, and how the light airframe produced minimal drag, allowing the aircraft to accelerate and decelerate with a responsiveness that no American plane he had flown could match, creating a profound cognitive dissonance between the perceived fragility of the Ki-43 and its undeniable flight capabilities. While his co-pilot and fellow observers whispered in astonishment, recounting tales of previous encounters with the aircraft in combat, realizing that now, for the first time, they could truly understand the psychological and physical advantages it provided its original pilots. And as the flight progressed into more daring maneuvers, the American pilot could feel the plane's nose drop slightly under high G turns, its wings flexing but never breaking, its rudder and elevators providing instantaneous feedback. And he began to experiment with aggressive rolls, inverted dives, and tight spirals, each one producing that same initial terror-tinged thrill, confirming that despite its seemingly fragile construction, the Ki-43 was designed for rapid, precise, and almost acrobatic maneuvering, unlike anything in the American arsenal at the time. And as the pilot pulled back on the stick for a sudden climb, feeling the G-forces press against his body, he marveled at the way the lightweight frame absorbed stress without the rattling, shaking, and potential structural compromises common in the more massive aircraft he knew. While below, the mechanics jotted notes furiously, sketching wing flex patterns, tail responses, and rudder efficiency, all while exchanging incredulous looks, whispering that this plane was nothing short of a revelation, a flying paradox that combined fragility with lethal responsiveness, simplicity with subtle genius, and lightness with astonishing control authority. And as the first minute of this unprecedented test flight drew to a close, the pilot brought the aircraft around in a wide bank, lined up for landing, and gently touched the wheels down, barely skimming the runway as though the Ki-43 had landed on air itself, rolling to a stop with a grace that contradicted its paper-thin appearance. While the mechanics cheered, laughed, and shook their heads, overwhelmed by the shock of witnessing firsthand an aircraft whose combat potential had been underestimated by American pilots, engineers, and strategists alike. And as the pilot climbed out, wiping sweat from his brow, he looked back at the aircraft with renewed respect and disbelief, whispering that it was, without exaggeration, like flying a paper airplane with the power of a fighter jet, a machine whose engineering genius could not be ignored. And that first impression, a mixture of fear, amazement, and inspiration, would set the tone for every subsequent test, maneuver, and flight, shaping the pilot's understanding of Japanese design philosophy, aerodynamics, and combat strategy, leaving them with a lingering, visceral sense that the Ki-43, delicate as it appeared, held secrets in its wings, fuselage, and engine that were only beginning to be understood. And as the sun set over the airfield, mechanics and pilots alike knew that this first flight was only the beginning of a deep, painstaking exploration into the mysteries of the paper airplane fighter, A journey that would challenge every assumption they had about aircraft design, performance, and the very definition of flight superiority. And as the aircraft rested quietly in the hangar at the end of the day, they could not shake the truth that they had just glimpsed something extraordinary. Something that combined beauty, danger, and ingenuity in a way that no American plane could replicate at the time, leaving everyone involved stunned, fascinated, and irrevocably changed by the encounter. And that opening minute of flight would forever be etched in their memories as the moment they realized that appearances were deceptive, engineering brilliance could hide behind a fragile exterior, and that the Ki-43, the paper airplane of the Japanese Air Force, was an aircraft whose flight defied logic, challenged perception, and demanded respect above all else. After the initial test flight, the American pilots could barely contain their mixture of exhilaration and disbelief. The Ki-43, with its deceptively fragile frame, had proven astonishingly responsive during the first minute in the air, and now the pilots were determined to explore its full capabilities. Mechanics and flight engineers had meticulously recorded every detail from the first sortie: wing flex, rudder responsiveness, elevator authority, aileron precision, and the subtle hum of the air-cooled engine. The runway, now littered with charts, instruments, and scribbled notes, became the staging ground for what would amount to an extended series of extreme aerobatic trials, designed to push this paper airplane fighter beyond any conditions it might have faced in actual combat. While the pilots mentally prepared themselves for the unexpected, aware that even a momentary misjudgment could be dangerous in such a lightweight and sensitive aircraft. The first maneuver involved tight, low-altitude turns, replicating dogfight conditions that the pilots had previously encountered against nimble Japanese aircraft in the Pacific. As the Ki-43 banked sharply, the light wings flexed, a subtle wave running along the trailing edges, yet the control remained perfect. The pilot's hands were glued to the stick, feet dancing on the rudder pedals, coordinating inputs to maintain precise altitude and trajectory. The engine whined in protest, high-pitched and vibrant, yet never faltering, providing exactly the thrust needed to complete the maneuver without the lurching, stalling, or loss of control common in heavier American fighters. Mechanics on the ground watched in awe, scribbling diagrams to capture the aircraft's fluid movement, noting how the torsional rigidity of the wings combined with a minimal fuselage weight to produce unprecedented roll rates and instantaneous response to control inputs. Next came inverted flight and rolls. The Ki-43, despite its lightweight design, handled inverted maneuvers with surprising stability. The pilot felt a strange paradox. The aircraft, delicate in appearance, seemed to resist turbulence and momentary disturbances, maintaining a level of predictability that allowed for precise, confident motion even when upside down. Each roll was executed smoothly, the controls returning to neutral with minimal lag, while the engine, remarkably, continued to deliver consistent power without overheating or sputtering. The American pilots, who had grown accustomed to more sluggish or resistant aircraft, marveled at the balance between fragility and performance. The Ki-43's design philosophy, maximizing agility while minimizing structural mass, became increasingly apparent with every twist and loop, and the term paper airplane began to take on a new, almost reverent meaning, a lightweight tool of war that moved like air itself, yet carried lethal potential in combat situations. Climb and dive tests followed. The pilots accelerated to maximum speed in steep dives, observing the aircraft's response under high stress. The fuselage flexed slightly, but the wings held firm, and the engine's air-cooled flat inline configuration prevented overheating even under continuous high-thrust conditions. In climb tests, the plane responded almost instantly to stick input, banking sharply to adjust trajectory without lag or stall, while the weight distribution allowed for sustained maneuvering without inducing fatigue on the control surfaces. Mechanics meticulously recorded airspeed, climb rate, stall thresholds, and roll performance, noting that the lightweight structure magnified responsiveness without compromising stability. Every observation reinforced a staggering realization. The Ki-43, though diminutive and underpowered by American standards, had been engineered with an uncanny understanding of aerodynamics, pilot psychology, and combat effectiveness. Then came the simulated dogfight scenario. Two pilots flew in tandem, testing coordinated maneuvers, attack runs, and evasive tactics. The Ki-43's extreme agility allowed it to outturn American fighters in mock combat, slipping past simulated gunfire and executing near-impossible evasions. Mechanics noted that the minimal drag of the lightweight frame, combined with the wing design optimized for lift at low speeds, allowed the aircraft to make sharp directional changes that were otherwise unattainable in heavier fighters. Even the pilot's grip fatigue and physical stress were reduced, as the controls required less brute force to manipulate, allowing for extended maneuvering with minimal strain. Observers on the ground could hardly believe what they were seeing, a tiny, fragile plane outperforming larger, more powerful American aircraft in every agile flight metric that mattered in close combat. Fuel efficiency during extended maneuvering was another revelation. While American aircraft consumed copious amounts of fuel under high-throttle aerobatics, the Ki-43, light and efficient, maintained energy over long sorties. Its engine produced just enough thrust for each maneuver, never wasting power, allowing pilots to sustain prolonged flight without the same logistical concerns of fuel depletion. Mechanics noted the engineering brilliance behind this balance. A machine designed not for raw speed, but for sustained performance, endurance, and precision. They began to understand that every design decision, light fuselage, flexible wings, minimal structural weight, optimized control surfaces, and efficient engine output, converged to create an aircraft whose combat advantages were not apparent at first glance but revealed themselves under sustained testing and extreme conditions. The final series of maneuvers tested coordinated banking, rapid climbs, and evasive spirals under load, simulating the aircraft's behavior in real combat. Pilots executed sequences that would have challenged even seasoned Japanese aviators, observing the Ki-43's predictable, responsive, and resilient performance throughout. The aircraft never faltered. Control surfaces remained precise, engine output was consistent, and even under high G turns, the plane maintained structural integrity without vibration or distortion. Mechanics and engineers, previously skeptical, were compelled to acknowledge the genius of the design. A fighter that looked delicate but had been optimized for real-world combat efficiency, agility, and endurance, capable of outperforming expectations while requiring minimal pilot effort to control. As the final minute of the test flight approached, pilots returned to the airfield, exhilarated and exhausted. The Ki-43 landed with effortless grace, its wheels barely skimming the tarmac, and rolled to a gentle stop as observers erupted in a mixture of laughter, disbelief, and awe. The aircraft, now revered as a paper airplane with extraordinary combat capabilities, had revealed lessons in aerodynamics, weight distribution, and responsive engineering that would forever influence the American understanding of enemy aircraft design. The opening flight, extreme maneuvers, and sustained tests had shattered preconceptions, leaving pilots, engineers, and mechanics alike stunned and profoundly enlightened. Fully aware that the Ki-43 was not merely a captured curiosity, but a window into the genius of Japanese fighter design, a lesson in how lightweight engineering, minimalism, and pilot-focused responsiveness could produce an aircraft that was at once fragile in appearance, yet deadly effective in practice. By the third day of testing, the American pilots had gone beyond initial amazement. They were now deep into an intense study of the Ki-43's hidden engineering secrets, and every flight revealed nuances that challenged their understanding of aeronautical design. Mechanics and engineers huddled around diagrams, cross-sections, and observational notes, attempting to dissect the combination of lightweight construction, airfoil design, and responsive controls that allowed this fragile-looking aircraft to maneuver with such uncanny precision. The first revelation came from the wings. The pilots observed how the thin, high-aspect ratio airfoils flexed during tight turns, providing just enough lift modulation to maintain stability while allowing rapid rolls and banks, unlike the more rigid wings of American fighters, which often caused heavy feedback through the controls under stress. The Ki-43's wings seemed almost alive, adjusting subtly to aerodynamic forces and granting the pilot a sense of effortless control, a responsiveness that defied all conventional expectations about the relationship between structural fragility and combat performance. The next discovery centered on the fuselage. Pilots noticed the carefully optimized weight distribution, with the engine positioned to maintain a low center of gravity while preserving nimble handling characteristics. This placement allowed the aircraft to change direction almost instantaneously, and when combined with the light structural frame, it enabled maneuvers that would have been impossible for heavier, more powerful American fighters. Mechanics measured stresses on the fuselage and control linkages, noting how the Japanese engineers had maximized material efficiency without compromising integrity, achieving a level of structural harmony that American designers had rarely encountered. Every rivet, panel, and support strut appeared meticulously calculated to balance flexibility with resilience, producing a machine that felt both delicate and incredibly strong under the right conditions. Control surfaces revealed even more surprising details. The Ki-43's ailerons, rudder, and elevators were exceptionally sensitive yet predictable, providing immediate feedback without overshooting or lag, and the pilots quickly learned that subtle inputs produced dramatic results. During tight maneuvers, the aircraft responded precisely, with minimal resistance, allowing pilots to execute aggressive rolls, dives, and climbing turns that would have been exhausting or unpredictable in American designs. The linkage mechanisms were simple but extraordinarily effective, highlighting a philosophy of minimalism combined with efficiency. Every component had a purpose. Every surface contributed to performance, and the aircraft's responsiveness was the product of careful thought, not brute force. Pilots began to realize that the term paper airplane was not merely a description of fragility, but a metaphor for elegant efficiency, a machine whose design prioritized performance through subtlety rather than raw power. Engine performance also contributed to the pilots' astonishment. Though the Ki-43 was underpowered by American standards, its air-cooled radial engine produced just enough thrust to allow agile climbs, rapid acceleration, and sustained aerobatics without overheating or loss of efficiency. Mechanics monitored temperature gauges, oil pressure, and RPMs during extended flight sequences, noting that the engine's design minimized friction and distributed stress evenly across moving parts. The lightweight frame meant that even modest power output translated into remarkable maneuverability, allowing the aircraft to exploit its aerodynamic advantages to the fullest. American pilots, accustomed to relying on brute horsepower for speed and climb, were confronted with a revolutionary concept. Efficiency and clever design could outperform raw power in practical combat situations. Further investigation revealed subtle aerodynamic tricks. The Ki-43's wingtip design minimized drag while enhancing lift, and the fuselage's smooth contours reduced turbulence, allowing for rapid changes in speed and direction with minimal pilot effort. Pilots observed how the aircraft performed high-speed dives and abrupt climbs with a level of control that made it seem almost as if the plane anticipated their inputs. Mechanics documented each observation, realizing that the Japanese engineers had engineered an aircraft that harmonized pilot, airframe, and environment, creating a synergy that amplified performance while maintaining simplicity. Every detail, from tail shape to control hinge spacing, contributed to an almost invisible layer of aerodynamic intelligence embedded within the plane. Landing gear design was another unexpected revelation. Despite repeated extreme maneuvers and low-altitude testing, the retractable gear absorbed shocks efficiently, ensuring smooth landings without compromising structural integrity. Pilots noted that the aircraft's ability to handle rough airstrips or uneven terrain exceeded expectations, particularly given the fragile appearance of the landing gear struts. Mechanics dissected the design, recognizing a philosophy that valued simplicity, resilience, and low-maintenance operation, critical advantages for aircraft operating in remote or improvised airfields across the Pacific Theater. Even small details such as tire composition and strut placement reflected a deliberate balance between performance and durability, a hallmark of Japanese engineering that American observers found difficult to replicate. The cockpit itself revealed further secrets. Controls were ergonomically designed for maximum efficiency, with minimal pilot fatigue even during long, intense sorties. Instrument placement, stick sensitivity, and pedal responsiveness were optimized to allow rapid reaction without confusion or overexertion. Pilots noted how the aircraft responded to minute adjustments, granting unprecedented precision during simulated dogfights. Mechanics documented every observation, realizing that the Ki-43's design emphasized not just mechanical efficiency but pilot-centered optimization, every system working in harmony to allow human operators to extract maximum performance with minimal effort. By the end of the day, the American pilots and mechanics were united in awe. They had uncovered layer after layer of hidden engineering brilliance, wings that flexed with purpose, a fuselage optimized for balance, control surfaces that responded instantly, an engine that maximized efficiency, aerodynamics that defied expectations. landing gear that absorbed extreme stress, and a cockpit designed for precision and endurance. The Ki-43, initially dismissed as a fragile paper airplane, had revealed itself as a masterpiece of thoughtful, minimalist engineering, a machine whose elegance and effectiveness were inseparable from its simplicity. Pilots left the airfield that evening exhilarated and humbled, understanding that what they had flown was not merely a captured enemy fighter, but a living lesson in aeronautical ingenuity, one that would influence their perception of aircraft design, combat tactics, and engineering philosophy for the rest of their lives. And as the sun set over the runway, the captured Ki-43 sat quietly in the hangar, small, unassuming, yet brimming with secrets that had left American pilots and mechanics utterly shocked, inspired, and irrevocably changed. By the fourth day of testing, American pilots had fully transitioned from cautious observers to daring experimenters, determined to push the captured Ki-43 to its absolute limits, and the airfield had transformed into a theater of audacious aerobatic trials designed to test every facet of the aircraft's capabilities. Mechanics and engineers meticulously set up obstacle courses, marked rapid turn zones, simulated dogfight scenarios, and altitude transitions that mimicked both combat and extreme weather conditions, while pilots prepared mentally and physically, aware that the fragile-looking aircraft demanded precision, respect, and an understanding of its unique handling characteristics to survive such extreme maneuvers. The first sequence of the day focused on rapid climbs and dives. Pilots accelerated the Ki-43 to maximum speed before pulling into steep climbs, observing how the lightweight frame responded under the sudden load and noting the subtle flex of the wings, which absorbed aerodynamic stresses without compromising stability, while the air-cooled engine, remarkably resilient, maintained consistent power, allowing precise vertical maneuvers that would have overwhelmed heavier American fighters under similar conditions. Next came a series of abrupt, lateral rolls and corkscrew maneuvers, designed to simulate evasive action during combat. The Ki-43, true to its reputation as a paper airplane, executed these maneuvers with astonishing agility, rolling and twisting through the air as if guided by an invisible hand. Pilots marveled at the responsiveness of the ailerons and rudder, which allowed sharp directional changes without inducing structural fatigue or loss of control, while the engine, despite its modest output, provided exactly enough thrust to maintain speed and lift throughout the sequence. Mechanics on the ground tracked every motion with instruments and sketches, recording wing flex, fuselage response, and control surface efficiency, and each run reinforced the growing realization that this small, lightweight fighter had been engineered for extreme agility, endurance, and precision. A combination that defied conventional American assumptions about horsepower, mass, and maneuverability. The extreme high-speed dives that followed tested both pilot skill and aircraft integrity. Pilots accelerated to near maximum velocity before pulling up sharply to simulate sudden evasions and attack recoveries, feeling the G-forces press against their bodies while the aircraft flexed subtly under aerodynamic load. Remarkably, the Ki-43 remained steady, predictable, and controllable, with its wings and fuselage absorbing the intense stresses without vibration, flutter, or compromise. Mechanics monitored every parameter: airspeed, lift coefficient, control responsiveness, and engine RPM, and documented what they described as a balancing miracle, an engineering achievement that allowed this seemingly delicate plane to survive and excel under conditions that would have challenged heavier, more powerful fighters. The pilots, simultaneously exhilarated and astonished, began referring to it with a mix of humor and reverence, as the paper fighter that defied physics, an acknowledgement of the paradoxical brilliance embedded in its design. Low-altitude precision flights became the next test. Pilots maneuvered the Ki-43 just feet above the runway and airfield obstacles, executing tight turns, rapid climbs, and sudden stops, while simulating enemy engagement scenarios. The aircraft's responsiveness was unprecedented. Even at minimal altitude, it executed turns with razor-sharp precision, climbing or descending almost instantly in response to stick and pedal inputs. Mechanics marveled at the effectiveness of the lightweight frame combined with flexible wing design, noting that this configuration allowed maneuverability and control unattainable in heavier American fighters, and that minimal mass reduced inertia while amplifying the effects of pilot inputs, creating a level of responsiveness that was both thrilling and terrifying. Observers realized that every element of the Ki-43 had been deliberately optimized to allow pilots to react instantaneously in combat, a revelation that further deepened respect for Japanese design ingenuity. simulated combat exercises tested the aircraft in tandem with American fighters, providing real-time comparison. The Ki-43 executed evasive maneuvers with such agility that American pilots, despite superior engine power, struggled to maintain a pursuit, frequently overshooting or lagging behind the paper airplane. Mechanics recorded acceleration, climb rate, roll rate, and turn radius, astonished by the aircraft's ability to outmaneuver heavier opponents while maintaining structural integrity. Pilots, now fully confident in the plane's capabilities, executed coordinated formations, attack simulations, and defensive spirals, noting how the light frame and aerodynamic efficiency allowed for extended sorties without excessive pilot fatigue or mechanical strain. The aircraft, initially dismissed as fragile, had proven itself in repeated trials, revealing performance advantages that American designers had not anticipated, and leaving pilots to grapple with the paradox that a 25-horsepower engine in a tiny airframe could outperform more powerful, bulkier machines in agility, precision, and endurance. Fuel efficiency and endurance tests added another layer of astonishment. The Ki-43's modest engine consumed significantly less fuel than American fighters, yet provided sufficient power to sustain prolonged aerobatics and tactical maneuvers. Pilots conducted extended sorties, pushing the aircraft through multiple consecutive maneuvers while monitoring engine performance and airspeed, noting that the air-cooled design prevented overheating and maintained consistent output throughout. Mechanics documented these observations meticulously, realizing that Japanese engineers had not only optimized the aircraft for agility, but also for operational efficiency, allowing it to cover greater distances with minimal logistical support, a crucial advantage in the dispersed and resource-limited Pacific theater. Finally, the day concluded with high-altitude agility trials. Pilots climbed to maximum operational altitude, performing steep banks, sharp rolls, and rapid descent sequences. The Ki-43 remained responsive and predictable, handling turbulence and wind shear with composure, while the engine maintained consistent output without signs of strain. Mechanics, taking careful notes, recognized the aircraft's engineering brilliance, an interplay of weight distribution, control surface responsiveness, and aerodynamic design allowed it to remain fully effective at all operational altitudes, challenging American assumptions about the relationship between power, mass, and flight performance. Pilots, exhausted but exhilarated, shared looks of disbelief and admiration, acknowledging that the aircraft's paper airplane appearance belied a lethal combination of agility, efficiency, and resilience. As the sun set over the airfield, the pilots brought the Ki-43 in for a flawless landing, the wheels barely skimming the tarmac, rolling to a stop with a grace that contrasted sharply with its tiny engine and fragile frame. Mechanics, engineers, and pilots gathered to debrief, fully aware that the day's extreme trials had revealed secrets and capabilities previously unimaginable. The Ki-43, originally dismissed as a delicate curiosity, had proven itself as an aircraft of extraordinary design, capable of maneuvering with precision, endurance, and efficiency unmatched by many larger, more powerful American fighters. That final minute of the day's tests solidified the aircraft's reputation. Fragile in appearance, yet deadly effective in performance, earning the respect and awe of every American pilot who had flown or observed it, and leaving a lasting impression that would shape their understanding of Japanese engineering, aerodynamics, and the subtle genius behind one of the war's most surprising aircraft. Following the extreme flight trials, American pilots and engineers shifted focus from pure aerobatics to the tactical implications of the Ki-43's performance, fully aware that they were observing a machine that defied conventional combat expectations. The initial impressions, light, fragile, and deceptively underpowered, had been thoroughly overturned. This paper airplane fighter demonstrated not only extraordinary maneuverability, but also operational advantages that challenged every American assumption about air combat dynamics in the Pacific theater. The pilots began running detailed simulations and mock engagements, testing dive and zoom tactics, low-altitude evasion, tight formation flying, and rapid altitude changes to understand precisely how the Ki-43's unique engineering translated into battlefield superiority. Every maneuver revealed subtle advantages. Its lightweight frame allowed for faster directional changes. Its responsive controls enabled immediate reactions to threats. And the efficient engine sustained prolonged aerobatics without overheating or loss of performance. One critical lesson emerged quickly. the Ki-43 excelled in low-speed dogfights. While heavier American fighters relied on raw power and inertia to outmaneuver opponents, the Ki-43's minimal mass and agile control surfaces allowed it to turn tighter and faster than expected, often positioning itself behind more powerful adversaries in simulations. Mechanics meticulously measured turn radii, climb rates, and roll responsiveness, noting that the aircraft's aerodynamic design, combined with its low wing loading, granted it an ability to maintain energy while executing tight maneuvers. Pilots, repeatedly astonished, realized that these characteristics explained why Japanese aces had been so effective in the skies, despite often facing superior numbers and technologically advanced American planes. Every mock engagement reinforced the lesson that raw horsepower was not the sole determinant of combat effectiveness. Lightweight design, responsive controls, and aerodynamic efficiency could outweigh brute strength when applied with skill. The Ki-43's advantages at altitude were equally revealing. High-altitude simulations demonstrated that the plane maintained stability and control during rapid climbs and sudden dives, allowing pilots to execute vertical maneuvers that could evade or outmaneuver heavier American fighters. Mechanics noted that the lightweight structure minimized structural stress, while the air-cooled engine performed consistently under sustained high-altitude operations, a stark contrast to American engines that risked overheating or performance degradation under similar conditions. Pilots observed how the aircraft's handling remained precise even in turbulent air, a combination of careful engineering and low mass that allowed for exceptional agility without sacrificing control. These observations led to tactical insights. Japanese pilots had effectively used the Ki-43's strengths to avoid head-on confrontations, exploit agility in dogfights, and maintain situational awareness, demonstrating that engineering subtlety could translate directly into battlefield dominance. Another profound lesson involved energy management during combat. The Ki-43's lightweight frame allowed pilots to sustain high G-turns and rapid maneuvers without excessive loss of speed, enabling extended engagements with minimal risk of stalling. American pilots had to adjust their expectations, recognizing that heavier aircraft, though faster in a straight line, could not match the Ki-43's ability to maintain energy through tight, prolonged maneuvers. Mechanics documented airspeed changes, G-forces, and control inputs across multiple trials, revealing that the aircraft's design effectively balanced lift, drag, and engine output to create a combat platform that was both nimble and enduring. This understanding reshaped American approaches to dogfight simulations, emphasizing pilot skill and maneuver efficiency over raw engine performance in predicting combat outcomes. Fuel efficiency and operational endurance provided further tactical insights. Despite its small engine, the Ki-43 could conduct extended sorties without refueling, a significant advantage in remote theaters where supply lines were limited or contested. Pilots tested prolonged flights with continuous maneuvering, noting minimal engine stress and stable handling, while mechanics recorded fuel consumption rates and engine metrics, confirming that Japanese designers had prioritized not only agility but also sustainability. This revelation underscored a tactical reality. A lightweight, efficient aircraft could outlast heavier opponents, maintain readiness across longer missions, and exploit opportunities created by American logistical limitations, turning engineering elegance into practical combat advantage. The lessons extended to pilot workload and ergonomics. The cockpit layout, responsive controls, and minimalistic design allowed Japanese pilots to operate the aircraft with precision under stress without fatigue. Even during extended sorties or rapid maneuvering sequences, American pilots accustomed to heavier, more cumbersome controls were struck by how the Ki-43's design emphasized pilot-centered efficiency. Every input produced predictable results. Every control surface was intuitive, and the aircraft seemed to respond to the pilot's intent almost instinctively. Observers realized that Japanese engineers had optimized the aircraft for human performance as much as mechanical performance, creating a synergy between pilot and machine that enhanced combat effectiveness. As mock dogfights continued, pilots gained a deeper understanding of the Ki-43's role in Japanese air strategy. Its light frame, agility, and efficiency explained how Japanese aces had exploited superior maneuverability to compensate for weaker engines and lighter armament, using hit-and-run tactics, rapid altitude changes, and tight-turning engagements to outmaneuver opponents with more firepower. Mechanics and pilots alike recorded every observation, sketching tactical diagrams and noting how subtle engineering choices, flexible wings, Low weight, efficient engine, responsive controls, directly translated into battlefield tactics. This insight provided a rare glimpse into the integration of design and strategy, showing that the aircraft was a product not only of engineering, skill, but also of strategic foresight in leveraging its unique strengths against the limitations of enemy aircraft. By the final minutes of the day's trials, American pilots had transformed from curious testers to fully engaged analysts, documenting lessons that would inform tactical doctrine, training approaches, and aircraft evaluation for years to come. The Ki-43, once dismissed as a fragile paper airplane, had revealed layers of complexity, ingenuity, and tactical brilliance that demanded respect. Its design, a careful orchestration of aerodynamics, weight optimization, control precision, and pilot-centered ergonomics, had created a machine capable of outperforming expectations in every metric that mattered in combat. As the aircraft rolled to a stop at the end of the day, engines humming quietly, mechanics and pilots exchanged looks of awe, fully aware that they had witnessed a combination of engineering, efficiency, and tactical insight that few American aircraft could match, and that the lessons learned from this captured fighter would echo long after the war, reshaping their understanding of aerodynamics, combat strategy, and the subtle genius behind the Ki-43's paper airplane flight. By the end of the testing program, American pilots and engineers had reached a profound and almost uncomfortable realization. The captured Ki-43, initially dismissed as a fragile, underpowered paper airplane, was in truth a masterclass in minimalist engineering, aerodynamics, and pilot-centric design, an aircraft that defied the assumptions of brute power and structural bulk that dominated American fighter design philosophy. Every maneuver, from high-speed dives to low-altitude tight turns, had consistently reinforced the paradox at the heart of the Ki-43. Delicate in appearance, yet capable of extraordinary performance. Lightweight, yet remarkably resilient. Modest in power, yet deceptively lethal in agility and endurance. Pilots who had approached the aircraft with skepticism were now forced to confront a combination of exhilaration, admiration, and disbelief as they documented the final series of flights and assessed what they had learned, knowing that this small Japanese fighter had provided lessons that would resonate far beyond its immediate tactical evaluation. The aircraft's extreme maneuverability remained the most shocking revelation. During the final aerobatic tests, pilots executed continuous rolls, sharp climbing turns, and rapid evasive spirals, observing the same astonishing responsiveness that had characterized the earliest flights. The Ki-43's lightweight wings flexed subtly under aerodynamic load, absorbing stresses without compromising control, while the fuselage maintained structural integrity even under extreme G-forces. Each input produced instantaneous reactions. Each maneuver reinforced the pilot's growing respect for Japanese design ingenuity, which had optimized the plane not for brute speed or firepower, but for controlled agility, endurance, and survivability in the unforgiving skies of the Pacific Theater. Mechanics recorded data on wing flex, control surface deflection, engine output, and airframe vibration, confirming that every detail, from rivet placement to aileron sizing, had been carefully calculated to produce maximum performance from minimal mass, creating a combat aircraft that combined simplicity and brilliance in equal measure. Engine performance, too, left pilots astounded. Despite its modest horsepower, the air-cooled Ki-43 engine sustained prolonged aerobatic maneuvers without overheating or loss of responsiveness, allowing pilots to explore the limits of the aircraft's agility without concern for mechanical failure. Extended simulations of dogfights, sustained climbs, and low-level evasion highlighted how efficiency, weight distribution, and aerodynamic finesse allowed the Ki-43 to outperform larger, heavier, and more powerful American aircraft in scenarios where nimbleness and endurance were decisive. Pilots marveled at the balance between fragility and reliability. A plane that looked vulnerable could survive repeated stress tests, repeated maneuvers, and intense simulated combat, leaving a lasting impression that appearances could be dangerously deceptive in evaluating enemy capabilities. The psychological impact on American pilots was profound. The Ki-43's performance challenged their assumptions about aerial combat, forcing them to rethink how agility, structural flexibility, and engine efficiency could overcome raw horsepower and heavy armor. Pilots reported a mixture of exhilaration, fear, and awe during the final series of flights, noting how the paper airplane nickname had initially implied weakness, but now symbolized subtle genius. Observers realized that enemy designers had created an aircraft that allowed pilots to exploit their own skills to maximum effect, rewarding finesse and precision over brute force, a concept that was both humbling and enlightening for American aviators accustomed to heavier, less responsive machines. Mechanics and engineers synthesized all the data, creating comprehensive reports on performance, handling, structural integrity, and aerodynamic efficiency. Each diagram, graph, and note told a story of meticulous design decisions: wings engineered for optimal lift and flex, fuselage weight optimized for low inertia, controls tuned for instantaneous responsiveness, and an engine designed for efficiency and reliability rather than sheer speed. The cumulative effect was an aircraft that, while fragile to the eye, could maneuver with lethal precision, endure sustained flights, and respond instantaneously to pilot commands, a combination that had left American testers both awed and unnerved. Simulated combat exercises during the final trials solidified these lessons. The Ki-43's ability to outturn, outclimb, and evade larger American aircraft underlined the tactical advantages that Japanese pilots had leveraged throughout the war. Even in mock engagements with superior numbers or heavier opponents, the aircraft's agility, efficiency, and precision allowed it to maintain control, exploit gaps, and maneuver predictively, demonstrating that true combat effectiveness was as much about design philosophy and pilot synergy as it was about raw horsepower or firepower. Pilots took careful notes, analyzing how each feature, from wing shape to control sensitivity to engine reliability, contributed to a coherent system of flight that maximized survivability, combat effectiveness, and pilot performance. As the final landing concluded, with the Ki-43 rolling gracefully to a stop, pilots and mechanics alike could hardly conceal their astonishment. The aircraft, which had once seemed fragile and insignificant, had revealed itself as a machine of extraordinary design brilliance, capable of feats that rivaled or exceeded heavier American fighters in agility, precision, and endurance. The opening and closing minutes of every flight had delivered moments of suspense, exhilaration, and disbelief, leaving participants fully aware that the plane's true genius lay not in raw statistics, but in the seamless integration of lightweight, responsive controls, aerodynamic efficiency, and pilot-focused ergonomics. Every aspect of its design worked together, creating a fighter that could outmaneuver, outlast, and outthink opponents in ways that had previously seemed impossible. By the time the final reports were drafted, American pilots, engineers, and mechanics had reached a consensus. The Ki-43 was not merely a curiosity, a captured enemy plane to be cataloged and studied. It was a masterclass in minimalist, efficient, and effective fighter design, a paper airplane that embodied the essence of subtle genius, and a reminder that appearances could deceive even the most experienced aviators. The lessons learned in aerodynamics, pilot-machine synergy, and tactical application would resonate far beyond the testing field, informing training, aircraft evaluation, and strategic thinking for years to come. As the hangar doors closed on the final day of trials, the captured Ki-43 sat silently, small, unassuming, and deceptively fragile, yet leaving an indelible mark on every American pilot and mechanic who had flown it, a testament to the enduring shock, awe, and admiration it inspired, and a final confirmation that the so-called paper airplane had proven itself to be one of the most surprisingly lethal and ingeniously engineered aircraft of its time. A lesson in precision, efficiency, and subtle brilliance that would never be forgotten.